All right, this slide has a lot going on, but we see the same three sequences we had on the previous slide. Okay, we've got sequence A, we've got sequence B, and sequence C. And I'm going to try to use the same three colors that we used on the previous slide. So for each of these, you're being asked to sort of think about what's happening with each of those different sequences. So we have sequence A, B, and C. I'm just going to highlight those so you can kind of connect where they go based on the graph to the left. So, and our tables. Whoops, let me get that highlighted here. All right, so we're just answering a series of questions about what the patterns are that you are seeing there, okay? So the first question is, how do the inputs n and the outputs t of n of each sequence increase? In other words, you know, our n's in all of our tables are increasing by 1. So we could probably just write that for all three. And you obviously can't write that off to the side. But for each one of those individually, you could say n increases by 1 for each table. Because it's a sequence, we're talking about the first term, second term, third term. That's what n stands for. Now, as far as t of n, our outputs, how are they increasing? Well, if we look at sequence A, you can start thinking about, and you can draw on these, all right? So, you know, what would you have added? I always start with adding. What would you have added to 27 to get 54? In this case, that would have been plus 27. If I add 27 to 54, do I get 81? Yep. And if I add 27 to 81, do I get 108? I sure do. So we're adding 27 each time. Now I'm going to go ahead and just answer all the questions for sequence A first. Is the rate of change constant or changing? Well, it's adding every time the same number, so that would be a constant rate of change. The next question says, if you knew a specific term, how would you find the next term for each sequence? For example, if you knew the 10th term, could you find the 11th term? Absolutely. If you knew the term in the last term, all you have to do is add 27 to get the next term. And then what family of functions, linear or exponential, best models each sequence? So when we look at sequence A, that looks like it's going to be a linear function. All right, now let's go up and do the same thing for sequence B. All right, next up, sequence B. So let's start with adding, okay? So we look at it and we ask ourselves, you know, we add a 9 to get 36, and that would be 27. What would we add to 36 to get 81? And that would be 45. And then what would I add to 81 to get 144? And that's 63. So I'm not adding the same number each time. And we can explore the idea of multiplication, but I want to dig a little bit deeper with my addition. Is there a relationship in how much I'm adding each time? In other words, let's look at this second difference, we call it. How much would I add to 27 to get 45? That's 18. How much would I add to 45 to get 63? That is also 18. So what I see is that I'm adding 18 more than what I added last time. Okay, so I'm going to add 18 more than what was added the previous time. Okay, so is the rate of change constant or changing? Well, we're not adding the same amount every time, so this is a changing rate of change. All right, let's look a little bit further here. If I knew a specific term, how would I find the next term of the sequence? Well, that would be a tough one for us to do here because we would have to know how much was added to get the previous term, and then we would add 18 more to that. So I don't know if we could just knowing what the term was without knowing the previous term as well. So we would need to know 2 terms previous. And then what family of functions, linear or exponential, best models each sequence? I would say neither. This one is not linear or exponential. what you're going to find a little bit later is that it is a familiar family, but it's not linear or exponential. All right, let's talk about that last sequence. So sequence C. All right, so we got to figure out what are we doing to the outputs to get the next term. So this one, maybe you'd recognize it right away. We're not adding something each time. If we did, we'd have to add 6, but if we add 6 again, we're going to get 18, not 24. So we're not adding something each time. And even that common difference, you probably already explored that a little bit. Doing like the second difference like we did for sequence B won't work either. This one's a little bit easier to see. We're just multiplying by 2. So you multiply each term by 2 to get the next term. So multiply by 2. Is the rate of change constant or changing? Since we're multiplying by the same term every time, this would be a constant rate of change. And then if we knew any term, could we find the next term? Absolutely, because we would just have to multiply by 2. And then what family of functions, linear or exponential, best describes that sequence, and that would be an exponential. And we've talked a little bit about that in some previous lessons.